Okay, so I've just put together 4 layers. The 4 layers I've put together are layers 2, 3, 4, and you can see the dots here, 2, 3, 4, and 5. And these are the layers that exclusively have the catch recesses in. And what I'm going to do is use a file to make sure that these catch recesses are the same all the way through the layers, exactly the same, so that the catch mechanism doesn't foul on any of the layers. So you can see the blade is in here. This is the pin on the blade. You can see the blade there coming out. This is just a practice blade. It'll be a different blade in the final thing. And so the blade is propelled out by this end being pushed like that. It can't come out of the knife because there's a pin on here, stops it going any further. That's the purpose of that pin. And then there's another pin, that's the back of the pin you just saw. And then there's another pin here with a little gap at the end around which the puller will engage, and the puller will pull the blade back in like this. Now you'll notice as the blade goes out, you'll just notice here, see the bit of the blade in there? See the bit of the blade in there? You might see it a bit better when I push the blade a bit more. See it move there? That's the end of the blade. There it is. That's the end of the blade that gets caught by the latch at this end and stops the blade coming out until the latch is released. Obviously needs to be filed back a little bit then, but that's exactly what this exercise is all about. And then when the blade is out, you can just see the end of the blade in this latch, this end latch. So that latch stops the blade coming back in until the latch here is released, then the blade comes back in. So those latches are critical. They're little spring latches. And now that I've got these 4 all lined up and bolted together, I can work on all 4 of these, and I know at the end of the day, when I finish, they will line up. So that's what I'm doing next. This is the latch plate. Not sure it'll make a difference, but for reference, the little notch to the left there faces towards the back of the knife, and the little dot faces towards the top of the knife, i.e. where the button, the finger button is. So this is the front latch with its spring and latch plate. You can just see the latch plate there towards the bottom, and it is made of steel, so it will wear well. And behind it is a spring. I think the spring is quite important. The spring has to be quite a large diameter so that it doesn't go eccentric in the hole. You know, it has to fill the whole of the hole. It also has to be very gentle spring, a very weak spring, because when the knife is retracting and deploying, the edge of the blade will rub against the catch plate, and I want that friction to be reasonably small. So the spring I've cut from a larger spring is this large diameter but weak spring, and I'll probably just tune that by cutting more off the helix so that I get it the right strength. You can just see the steel latch plate in there, and of course what happens is when you pull the slider back, this ramped end on the slider, at the moment I can't Yeah, when it's engaged I can't push the blade back, but when this slider comes up you can see it pushing the steel plate, and then that does allow the blade to retract. And at the same time you push the slider back, of course you're charging up the springs to flick it back. So that's the front slider, and the back slider will be similar. I've recut the layer 3 on the CNC in steel instead of aluminium. For this layer, the knife slides in and out here. The knife will obviously be of steel, and that's the blade material, and therefore I wanted it to be housed in steel for wear and friction purposes. This was really hard on my CNC machine to cut. My machine's not really strong enough to cut steel, so I ran it really quickly, lots of cut in oil, and just advanced the bit down 0.1 of a millimeter and ran around the outside 20 times to get to cut through this, or 30 times. Still need quite a bit of filing of the catch recesses because the 3mm bit obviously couldn't get in accurately enough. This is supposed to be 3mm thick steel, but in fact it's 2.85. And it would be great if the blade was a little bit less than that, but in fact it's 3.12. So I've got a 0.27 millimeter issue here. Ideally this wants to be at least 0.3 thicker. One possibility to do that is to get a thicker piece of steel, but I don't have any, and it would probably mean getting a 4mm piece of steel and machining it down, which might be tricky, but I might do that. The other option is to take a thin packer, but this is too thin and I don't have any that are the right thickness, and it'd be a little bit messy having a very thin aluminium sheet packing out. So I think what I'll do is I'll use this high strength steel epoxy. I've just done a test here to make sure that it'll stick, and it does, because that's what it's for. And this comes out as like a very hard plastic, and what I'll do is I'll coat all this with the good thickness of it, and then I'll put that on my CNC and I'll just machine this down, and then I'll try it, machine it down, try it, and keep machining it down until this is the perfect thickness for the blade to slide in and out. So what I've got to try and do next, I think, is to try and machine this blade steel into the knife shape on my CNC. Like, this is going to be really hard because it's very hard. There's 3 layers. The outer layers are hard and the inner layers are very hard. So we see how we go. At the worst, I'm hoping I can at least get a sort of outline of a blade accurately by the CNC that I can then cut and grind and just work my way in towards the line. If everything goes superbly well, it might even cut through, although I might lose a couple of bits. I lost one bit on this, but luckily it just about cut it through when I lost the bit. So yeah, I'm pleased with that. That's good, and we're getting there slowly. So I wish to increase this sort of knife blade keeper layer by probably about 0.5 millimeter, and so my idea is to roughly apply some high strength steel epoxy, as I have done here, and then I will use my CNC to machine this off accurately over the whole length of the keeper, and I'll run it several times until I get the right thickness that just lets the blade slide without it being too loose. So this is my plan. So I've got this CNC to machine in a flat portion, which is this whole area, so that I know this is really flat relative to the CNC machine. Probably not totally necessary, but anyway. And this groove is exactly the same shape, should be, as the keeper. Should fit in like that, and then that should hold it reasonably tight, I think, for me then to know that this is totally level, top and bottom, parallel top and bottom when I machine off the epoxy. And yeah, we'll give it a go and see how it works. This is the spring, which does obviously all this snapping back together with the two sort of hooky things. Some designs have a double spring side by side, but that was too difficult to get them in the width that I've got. The spring has to be this sort of length, really, and it has to be powerful enough to flick the blade in. But also, if the spring's too short, the extension might end up damaging the spring. I didn't have a spring with all these qualities. Also, it has to be the right diameter. It has to be the maximum diameter, really, that will fit in. So I wound this spring from piano wire. I've got a selection of piano wire here. I tried different thicknesses. And because of the springy nature of piano wire, I wound it round a drill bit smaller than the final diameter, because when you release it, it tends to spring out and increase its diameter slightly. In addition to that, I've also taken out a groove here to give it a little bit more space, because it was just touching the top, and any sort of friction's pretty sort of deadly for a knife like this, which relies on the spring flicking part of the motion and then the momentum carrying the blade out. So friction is something to be avoided at all costs. I might well have to adjust the thicknesses of these hooks now that the clearance above everything is increased a bit by this much. So you need to look at that separately. Okay, so I've operated the knife a number of times and it stopped working, and I've taken it apart to see why. This is the guide that stops the knife flying out the front, with this pin here. What's happened is that the spring is so powerful, it's fired the knife out, and the steel pin has hit against the end of the aluminium and distorted the aluminium. The aluminium's distorted upwards, and that means that the knife now has got more friction acting on it. Also, what happened was that the pin, which was crashed against the end a number of times, actually fell out of the hole. So surprised me, because it was such a tight friction fit, I had to drive it in with the vise. But obviously the impact just loosens it and drives it out. So I've reset it and I've epoxied the back here. And if that doesn't work, I'll have to consider some other things. I think it'll be very hard to thread this steel because it's so hard. So I might have to try and weld it, but that might affect the heat tempering of the blade. So I'm not sure what I'll do there. And I think as far as this is concerned, I will put a steel insert at the end here for it to crash against. And as far as the spring is concerned, I've wound a slightly less powerful spring, and we'll see if that does the trick.